The lives we live today and the lives we aspire to in the future are all dependent on critical infrastructures, including energy, transportation, and manufacturing. Emerging technologies will disrupt how we build, design, and operate critical infrastructures. If we look at AI and autonomy, these have great potential to improve safety and to improve efficiency. But these technologies come with new risks which we don't necessarily yet understand.
But now we've got systems that learn, systems that change, and the world around them is also changing in ways that they might not have anticipated.
To move to a net zero world, we'll use new fuels and we'll use new approaches to getting energy. And with those systems, we have very little historic understanding. To see improvements in safety, we really need to understand how a system's actually behaving in real time.
Our critical infrastructures are also impacted by climate change. More frequent severe weather patterns, rising sea levels, and even changes to the oceans themselves expose vulnerabilities in our infrastructure systems.
Building climate resilient infrastructure requires a long-term strategy.
As these accelerating technical, societal, and physical changes happen, we need to ensure critical infrastructures remain resilient and sustainable, and ultimately do not threaten people's safety. When we talk about critical infrastructure, we're interested in two elements of their safety. The first part is about the resilience of these infrastructures, so they continue to maintain the critical services that we are relying on. The second element of safety is about people, the people that work on and interact with this infrastructure. They need to be safe when they are carrying out their jobs. Infrastructure is made up of an interconnected set of systems, and it's across the interfaces between those systems that we start to see risks to safety occurring. So at the Foundation, we are working with partners in order to understand exactly how those systems work and how we need to govern those systems in order to make sure the right decisions are being taken.
The growth of offshore wind farms offers technical challenges. I started my PhD in 2021 at NSERC, focusing on the protection of offshore wind turbines using low-cost, damage-tolerant sacrificial coatings with sponsorship from Lloyd's Register Foundation. With the development of high damage-tolerant coatings as thermal spray aluminum, we are going to reduce the frequency of maintenance and the human intervention, and we can mitigate the risks associated with offshore operation.
The Centre for Assuring Autonomy is developing concepts, models and methods for assuring the safety of robotics, autonomous systems and AI. And we're doing that in order to be able to adopt digital systems into the world and make it safer. The potential for AI and robotics to really impact people's safety can only truly be realised if we have confidence in those systems, if we know that they're safe when we deploy them. Working with the Lloyd's Register Foundation has meant that we can really focus on just that question. Without their support, this work would not be possible.
So the Data-Centric Engineering Programme at the Alan Turing Institute is looking at how we can revolutionise engineering by taking tools traditionally used in data science, machine learning and artificial intelligence and starting to research and develop new methods specifically for engineering to improve safety and reduce emissions. So Lloyd's Register Foundation have been an excellent partner for us through their network of other researchers globally and really helping us to move from being perhaps quite UK-centric and research-focused towards the future where we want to have real-world impact across the entire globe.
As we look to the future, there are new emerging technologies that are coming, new ways of thinking. Through developing partnerships, we aim to create infrastructures that are more sustainable and resilient into the future.